Now in this session we'll finish off the example we're doing of how to convert a given general grammar, context-free grammar, CFG, into CNF, Chomsky normal form. And we got to the stage we're now eliminating, so we're in step 3. We're eliminating the unit rules, and we found 4 of them in the grammar we're given, and we've done 2, and we will now do the 3rd and 4th. We will eliminate the 3rd and 4th unit rule and make the corrections by adding other rules that are effectively equivalent, though they will recognize the same strings as the rule we threw out. Rules. Okay, now what are they? What are those 2 unit rules? Well, one is A arrow B. Okay, remember that? A arrow B, and that's the 3rd one. And the 4th one is A arrow S. Go back previous session if you want to see where that 3rd and 4th unit rule came from. Okay, so A arrow B. A arrow B. So we throw that out, A arrow B, and so we look for a B on the left hand side. Is there one? Yes, here's one. B arrow little b. Okay, so we'll add a rule, A arrow little b. A arrow little b. So we add that, and we put a double wiggly line underneath it to show that that rule has been added. And the rule that was there, A arrow b, I think that should be eliminated. Okay. Right. Alright, so that's the 3rd one. Now, A arrow S. A arrow S, that's the 4th one. So you eliminate that rule, A arrow S, because it's not in CNF. A arrow S. And then you go looking for S on the left-hand side of your other rules. So, well, here it is. So all these, so A arrow S gets removed, and then the S arrow all this stuff. So the rule that you add will be A arrow all this stuff. So A arrow all this stuff. So 1, 2, 3, 4, 5 rules you add, okay, and underlined. So you've added those. Yeah, so the B's gone, right? So you just got SB here, little b, yeah, so that makes sense. Alright, so that's now, that's the current grammar, the grammar so far that we're, and we're getting there. I mean, have a look. We've still got like 3 variables in right hand side here, so that's not standard form. Chomsky standard form. That is, isn't, is. So we're getting there. We're progressively getting it more and more into CNF, into standard form, Chomsky's standard form. Okay, so now move on to step 4. And what do we do then? Well, we could create, so here's a rule, it's not arrow ASA, that's obviously not CNF, right? It's got 3 variables in it, so we'd like it to have 2. So let's create a new variable, call it A1, and let A1 be replaced by SA. So A1 arrow SA. Right? Now with a special case, in rule 4, when you had, when little k was 2, what did you do? Just a minute, I need to look myself. you create a new variable u and create a new rule u arrow little u. So so your u here would just be a u arrow b. So you put a u here, and then so you'll have a u. Oops. Oh, wait a minute. So I'll have u1 and u2. Okay, so that's okay. They're two variables. So that's standard form. And then you'll have a new rule that u1 will arrow little a. Now it's a single terminal. That's okay. And u2 arrow b. Puzzle. That's not. Well, you're gonna have to play around, with this till it crystallizes. Okay. Well, here's. You have to do a bit of deduction, detective work, and so on, figuring out all the little details of how this works. It seems a bit more subtle than it looks, right? Okay, so let SA be U1, so you'll have that, and then so U1 equals SA, that's alright. So where is U1? Oh, we're just calling it U. Oh. Okay, so There are several steps here that have been amalgamated. Instead of having a whole bunch of separate UIs, they've just simplified it to just a single UI and a rule U arrow A, I guess because the terminals here are all A's, pretty much. That's allowed you to simplify it. Well, okay, we'll work on it and see if you can get this S. So the SA, that becomes U1 or A1, so that's here added, rule added. So the A becomes a variable U. That's a single terminal, don't change it. Okay. So are we reverting back to step 3? Because here again we've got when you look at it, here we've got a unit rule. So I guess they're going back. Well, here it is summarised. Do that for homework. You're going to need to understand this well to do the exercises. So give it some thought and see if you can work out why this is the case. Right? Okay, well, I'll move on. I don't want to get too bogged down. All right. So next section, whole new topic, a major topic, because it's a new kind of automaton. And characteristic of it is that it has a stack. And what's a stack? Well, we talked about a stack a bit very early on in this lecture 2, in fact. Like a stack of plates, like a pile of plates, one on top of each other. In this context, you're not having plates, you'll have symbols that are stacked on top of each other, in a sense. And that stack can be infinitely deep. So you're no longer talking about a finite automaton. Right? It's effectively infinite. And we're leading in gradually, gently, towards the concept of a Turing machine, which will be the next chapter and the next part, like 3 main parts to the whole text. So chapter 3 will be the beginning of the topic of computability, which personally I find the most interesting of the 3 parts. I find this part a little bit dry, just talking about languages and so forth. But the second part is more fun, conceptual fun, in that it proves mathematically that some things just simply cannot be computed. And that's a big shock to a lot of people. A lot of people under the impression that computers can do anything. Right? Well, they can't. There are some things that you can mathematically prove they cannot do. Right? They're just, some things are not computable, unable to be computed. And I find that fun. And the third part, I've said several times earlier, is that's more on the issue of complexity. In other words, for those problems that can be computed, can be solved with a computer, some of them are fairly easy to do and others are very hard. So you categorize problems into levels, different families of, different classes of hardness. How easy or how hard is it to solve them? And hardness usually means like how many steps involved.